Okay, let's just dive right into this explainer because today we are unpacking a truly groundbreaking SSRN paper that fundamentally challenges everything Silicon Valley assumes about artificial intelligence. The paper is called The Einstein Test and Beyond, The Architecture of the Semantic Zero by Eric Blattler and Tony McCaffrey. And the core argument here is absolutely fascinating. Basically, what we call AI hallucination isn't just some glitch. It's not a lack of training data, and it's definitely not a bug you can just fix by throwing more computing power at it. It is an inescapable structural flaw in the architecture itself. We are going to explore exactly why that is, and more importantly, how we can actually fix it. But before we really get going, I want to give a quick state-of-the-art disclaimer. This explainer was produced using the tools of Google Notebook LM, based on SSRN paper 6977185. And as the authors explicitly note in their disclosure, while AI tools played an essential part in accelerating these concepts, acting strictly as formal cartographers to navigate existing domains, the conceptual framing, the structural arguments, and the actual discovery of the semantic zero remained fundamentally human. Because of that, you can rest assured that this explainer is a completely hallucination-free, human-supervised journey through the material. So to truly grasp the limits of our most advanced frontier technology, we arrive at Section 1, the Roman calculator problem. This ancient problem brilliantly illustrates the core issue we are facing today. Imagine taking the greatest Roman scholar who ever lived, locking them in a room with unlimited clay tablets, and handing them a modern calculus problem. They would fail every single time. Why? Well, because the Roman numeral system structurally lacks a zero. There is literally no manipulative mathematical symbol for an empty positional column. And just like that Roman scholar, current AI architectures rely on what is known as a softmax engine. This engine works by distributing probability across an established vocabulary, which means it mathematically has to make a guess. It has no semantic zero. There is no structural address in its system to honestly just say, I do not know. When it hits a blank, it's mechanically forced to guess. And you know what we call that guess? A hallucination. So, how does this missing structural piece actually impact reasoning? That brings us to Section 2, failing the Einstein test. Demis Hassabis proposed this ultimate benchmark for AGI. He asked, if you trained an AI only on pre-1911 knowledge, could it autonomously discover general relativity the way Einstein did? The empirical equivalent to that is the ARC-AGI benchmark. It tests true fluid intelligence, basically measuring how well a system adapts when it doesn't already know what to do. The crucial takeaway here is that while human children establish the baseline at a perfect 100% on this benchmark, the absolute most advanced frontier large language models completely collapse. They score a staggering 0.26%. That is a dramatic 186x drop compared to human intelligence. And this catastrophic collapse is exactly what happens when you test a system that cannot handle novel friction. Because the language model lacks that semantic zero, it can't pause its execution to mint a brand new discovered feature. It's that Roman calculator again, just wildly rearranging tally marks, hoping for the best. This proves, without a doubt, that hallucination and the failure to genuinely reason are not data scaling issues. They are the direct symptom of a machine operating without a semantic zero. Naturally, you're probably wondering, well, why can't we just build a bigger AI brain? Why can't the big tech companies just throw more data centers, more compute, and billions of more parameters at this until the hallucinations just vanish? The answer is something the authors call the gradient horizon. AI training relies on gradient descent, which is fantastic at finding local minima, basically optimizing within a predefined space, but an isolated AI is trapped inside that space. True innovation, like Einstein realizing that gravity and acceleration are actually the same thing, requires breaking the old frame entirely. It requires biological friction. It needs a visceral, real-world encounter with physical reality that a sealed-off AI just cannot experience. An AI can't feel the floor drop out from under it in a falling elevator thought experiment. It structurally lacks the biological grounding required for genuine, completely novel discovery. Fortunately, there is a mathematical cure for this. We don't have to stay stuck using Roman numerals. Welcome to Section 3, Finding the Semantic Zero. The first key to fixing this is the canonical concept identity, or CCI. Think of this exactly like the empty tens column in Arabic numerals. It provides a mathematically discoverable, universal coordinate for any concept. Before any inference even happens, the CCI gives the AI a stable address where a semantic zero can finally exist. It structurally provides a placeholder that says, hey, we know this concept exists, but we currently have zero verified knowledge about it. The second key is the contextual token instance, or CTI. If the CCI is that empty positional column we just talked about, the CTI is the biological observer physically writing a digit into that column. It's a cryptographic seal of a real-world observation. This ensures the data isn't just some floating unverified token grabbed from the internet. It acts as the semantic DNA of a verified human observer, securely anchoring that specific piece of knowledge right back to the physical world. When you contrast these two topological blueprints, the massive shift becomes incredibly clear. Current AI models suffer from what's called Shannon information collapse. Basically, tokenization irreversibly discards where the data actually came from, making a verified laboratory measurement look exactly the same as a random internet rumor. But in the semiotic web, we get a triadic restoration. Meaning is strictly anchored to a verified observer via that cryptographic seal, well before any inference takes place. Honest ignorance becomes a structural reality, and truth is permanently bound to the real world. Let's see how these keys build an entirely new foundation in Section 4, the Protocol of Meaning. The concept of the sealed manifold absolutely nails why current safety fixes just aren't working. Safety tuning in AI with RLHF is honestly like trying to push an air bubble out from under a sealed sticker. The total volume of hallucination is mathematically conserved within that sealed manifold. The only real mathematical cure is an external boundary condition. You literally have to physically puncture that sealed manifold with a needle of verified human reality. And on a global scale, that puncture looks like a universal verified ledger. Let's look back at Einstein for a second. When Arthur Eddington's 1919 eclipse expedition physically proved general relativity, that published observation acted as an exact, verified puncture. In the semiotic web, publishing a verified CTI generates massive semantic gravity. It permanently alters the curvature of the network, instantly outweighing outdated models for all future queries. Because it requires cryptographic provenance, unverified fake news structurally reduces to having zero mass. Understanding this alters the entire landscape of how we think about computing. This brings us to Section 5, the Copernican AI shift. For years, the tech industry has operated under this incredibly outdated Ptolemaic view, the assumption that intelligence is a discrete stock, an asset you can just hoard inside a single, sealed-off data center. But history shows us that's not how it works. Einstein didn't invent general relativity alone in a sealed box. He relied on Grossman's math and Eddington's observations. We have to embrace the Copernican reality here. True intelligence is a dynamic, ephemeral flow of verified gap closure, running through a distributed network, a holonic federation, really, of both humans and machines working together. In this brilliant new model of semantic space-time, we finally achieve the perfect partnership. Humans, with our biological friction and messy lived experiences, remain the ultimate definers of epistemic gaps and the necessary anchors to physical reality. Meanwhile, AI, finally freed from the burden of being mathematically forced to guess, can serve as our perfect hallucination-free mathematical cartographer, navigating those empty positional columns that we provide. So I'll leave you with this final thought for today's explainer. Is the industry going to continue trying to brute force a completely flawed mathematical notation, burning immense energy to build larger and larger Roman calculators? Or are we ready to step into the Copernican completion, mapping out the semiotic web where honest ignorance and verified truth finally have a structural home? Thank you so much for joining me to unpack this, and I'll catch you on the next one.